Hello and welcome to week 3 in statistics, and off we go to the races. Now we're talking about data and distribution, the numbers that we are collecting when we are engaged in research and psychology. And I want to first start off when we're talking about data and distribution. Data is, and that is both the singular and plural version of that word. So data are and data is. Whenever we're referring to, there's no datas, it's data are. And like data are profoundly important. So it's the actual individual scores on something, let's say my IQ score, and a distribution is the term we use for a collection of those scores. So we have a data, one score, and then the distribution, which is a collection of those scores. So when you're engaged in research, you collect data and you result in a distribution of that data or distribution of scores. You can use those, we will take those distributions and apply statistical analysis to them. Now, those specific data refer to the ways in which we measure variables. Now, the variables are the psychological or influential characteristics of our study. If we're looking at the effect of temperature on test taking, then we define the temperature in degrees Fahrenheit in order to give us data and distribution on that. And we look at scores on the test in order to give us data and distributions on scores of the test. And then we can apply statistical analysis as to how one affects or is related to the other. And so those are the terms that we're going to be using. Now, data is defined in 4 different ways, and we refer to those as scales. So we have data, distribution, and the scales apply to what kind of data are we collecting, and that definition is key in understanding which statistical tools are the most logical and viable to use. So here we have that graphic within the course book here. Now, I want to point out right above this table, you see there's a link. Visit the website and complete the activity. This is, of course, optional, but if you go to that website, it gives you the opportunity to match particular kinds of data to what kind of scale it is, which is a really great exercise here. But let's talk about these. You have nominal, which is uncategorized, unordered categories such as names, the university you went to, those kinds of just apples and oranges. There's no numerical equivalent to that. Then we have ordinal data, and this is it's names, but they're in order. So A, B, C, D, F, for example, would be an ordinal. We know that A is more than B, but we don't really know. There's not really kind of an equal spacing between those. Now, then we get into interval. Now, the key to understanding interval is to really look at its most common application, and that is in the scales that we see when we're asking someone to rate something, say on a scale of 1 to 5. There's no 0. You can't not participate. You have a 1, 2, 3, 4, 5. And by by using numbers, we actually make what would normally be an ordinal scale, we now make it an interval scale. Because, for example, I could do a Likert scale, and I could just use colored balloons. You have blue on one side and red on the other and yellow in the middle, and that's how I'm going to rate it. Okay? I can do A, B, C, D, E. I can do A, B, C. I can do apples, orange, bananas. I can do any one of those, and they would be ordinal. Interval allows us, it's just like ordinal, but it allows us to use the numbers. So if 1's a low number and 5's a high number, then we can do actual mathematical components, and it's a cheat. It is a cheat on being able to do statistics on ordinal data. Now, the reason why it's a cheat, and I want to explain this a bit because it's important to understand these Likert scales. The statistical test that we use for ordinal is usually frequency distributions, which is what we're going to be talking about in this particular class. Let's say we're looking at A, B, C, and D. Let's say that's my data. I could theoretically say I can't compute it if my data is A, B, C, D, F, but I could look at what's the middle. I could maybe look at central tendencies such as the mode, or I can look at the median, what's the one in the middle. But I can't calculate average. There's no average. It's just A. If that's the data is A, B, C, D, F, there's no B minus. There's nothing in there. The same is with interval data. You rate something 1, 2, 3, and 4. That's just a numerical reference to what is an interval, an ordinal scale. Because in truth, when you are rating something, and you're looking at 1, 2, 3, 4, 1, it's the worst thing. 3, it's neutral. 5, it's the best thing. If you think about the reason they call it interval is the interval between 1 and 2 is not necessarily the same as between 2 and 3, 3 and 4, and 4 and 5. In fact, what it actually looks like in terms of opinions is 1 and 2 are really close to each other because you'll say things were bad, but they weren't awful, and then there's awful. And then on the other side, you have 4 and 5. Like things are really good, but there was just a few things that were off, and then everything was fine. So the actual intervals between those are not equal. We get that in the next one. So if somebody picks a 4, that's not necessarily twice as much as someone who picks a 2. But it's a cheat. We do it anyway. So even though in a Likert scale, 1, 2, 3, 4, 5, you do them all the time. We distribute them all the time in terms of course evaluations and whatnot. I can get a course evaluation that says I got a 4.3. Nobody gave me a 4.3 because there's no such thing as a 4.3. And it's an average, let's say, that's sort of resting within those numbers. It's actually a false number. But it's useful, and we have it as a separate category because it's so useful. Now the next one is called interval. Now interval scales have a 0 point, and the difference between 2 and 4 is that 4 is twice as much as 2. So it runs along that set like a number line. This is such as age or IQ or the number of books that you have or whatever, those kinds of things. Those are, a person who has 2 books has half the number of books of someone who has 4 books when we're counting. So when you look at the data, that's going to be coming up in one of the special assignments, when you look at the data that you're going to be collecting in your studies, you want to understand how this data is working. So if you're collecting sex and male and female, that is nominal data. We may use that actually to define groups rather than, is there an average? Is there a F.6? No, there's just how many F's, how many M's. And if you go into gender, you can have an even wider diversity of those different things. Are you measuring anything on an ordinal scale, where things are in order, but they're not necessarily, there's an order to them, such as, let's say you were going to measure the degrees that they have, whether they high school or some college associate's degree, some toward a bachelor's degree, master's degree, PhD. Those are in order, but you're still just operating on frequency distributions there. There's probably going to be a lot of you doing interval scales, lots of ratings, lots of, that kind of thing. And then there's going to be a bunch of you that are going to be doing ratio type data. You'll see when we look at the decision trees associated with picking our statistical analysis tools that it asks about the data, asks about the scale of your data. It's a very important part of this process. When we're looking at counting, we're looking at frequency distributions, where we see frequencies, the number of a particular thing. Let's say we're looking at an interval scale. How many ones, how many twos, how many threes, how many fours, and how many fives? That's way better information from a Likert scale than the average, because Likert scales in some tend to be polarized. The people either really liked you and they didn't, at least in my experience, right? But if a whole bunch of people like me, but there's 3 people that gave me a 1, I'm actually very interested in that one, even though it just pulled my average down to 4.6. Oh, I'm great, I'm 4.6. I'm actually really curious as to those 3 people that pulled my average down by putting the 1. So frequency distributions, actually that counting, is very, very vital when we're looking at interval data. And of course, the other two, we're looking at nominal and ordinal data as well. Percentiles are, if you piled everybody up and it went from 0% all the way up to 100%, where's the score in terms of, are you higher than 50%? Are you higher than 56%? Are you higher than 90%? So we see percentiles coming into that. You've heard that term. We're going to be looking at that concept. We're also going to be looking at, there's things like quartiles, where there's the bottom 25%, the lower middle 25%, the upper middle 25%, and the upper 25%. We might have heard this. That's the same sort of thing. The 1%. They're also in the 99th percentile, meaning higher than 99% of the distribution. We're going to be looking at bar charts and the shapes that bar charts are frequency distribution, how much of each one. So we look at, let's say we're looking again at how many ones, how many twos, how many threes, how many fours, and how many fives. And you have bars representing the numbers, but then you have a shape that goes across the top. And that shape is called a curve. It's representing that distribution. And its shape, however it is, whether it has humps or whether it's all piled up on this side or it's all piled up on this side, that's called skew. Those tell us information, descriptive information about the distribution. Okay. Now, I want to just make sure that you understand the term skew, and that is when it's piled up on one end or the other. And we refer to them as negative or positive skews. Now, just for some clarity, you have the pile up, and then you have the tail, which is the low. It looks like the low end. The direction on the number line where the tail is pointing is the type of skew. So it's piled up on the positive side and the tail is to the negative. That's called a negative skew. It's piled up on the negative side and it tails to the positive. It's called the positive skew. So the skew refers to the position of the tail, not the pile. I didn't make it up. Somebody else did. Okay. The discussion: find a distribution on the web and explain it. Find a set of numbers on the web and explain it. In the quiz, explain why everything that we've just talked about is descriptive statistics and not inferential or predictive statistics. Explain why they're describing the data. Remember, from those goals of psychology, we're still in describing. Okay? And then I give you a study, and I want you to tell me what the operational definition of that study is, of the variables in there, and the type of scale that is. Now, the operational definition is whatever construct whatever my variable is, like age. Now, what's the age? Number of years. I could also say number of weeks, number of days, hours, months. I could measure that in many ways. Age, I can even put them together. I can put, age 0 to 5, 6 to 10, 10 to 15. I could do that. That's the way I'm measuring that. So what is it? What kind of scale is that in that study? And the assignment, interesting that I just described those groupings. The assignment, I've given you some data, and I'm asking you to do all the computations that I exemplified in the course book. You're going to be doing the frequency distribution, counts, percentages, cumulative percentages, but you are going to be grouping the distribution into ranges. So rather than looking at every little score, you're going to be grouping them together into ranges of scores, which produces a particular frequency. So how many scores lie in from the bottom to the top of that range? That's your frequency, not every single score. To do that requires some change in terms of defining the formulas that you use in Excel to do this. So this is a little bit of a research project. How do you do that? It does involve using greater than and lesser than, those wedges there, greater than and lesser than, those less than, those become part of your formula when you're defining what you want it to count. So I count all the variables that are greater than this but less than that. And it takes some logic to kind of understand what numbers to put in there. So good luck on that. All right. And lastly, I've still not graded any of the proposals, and I apologize for that. I've been having some difficult time management things going on here. Kind of a busy guy right now. So effort is there. I will be trying to get those out to you. As I do them, I'm going to send them out to you so you can start responding right away. And I have not forgotten those things. It's still pretty early in the semester. So that is this week's work. Look forward to a nice, healthy discussion here. What was that on? That was going to be on finding distributions on the web and explaining them. What are those distributions telling us in terms of frequency distributions, counts, skew, those kinds of things, and find those on the web. Don't find definition ones. Find data in like a news article where they use a distribution. Don't look up what's a skewed data set. It's just going to come up with an example. Find it on the web. Find it in a news article. There's plenty of them. Put the right search category, the right search terms in your Google search, and you should be fine to get that. All right. Have a great week, and I will see you online. Take care.